I have a dream that one day
T minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition and liftoff of Ares 1X, testing concepts for the future of new rocket design.
Welcome to the third lesson on APs. In this lesson, we'll be looking at using the sum formula. There are four standard techniques that we will be discussing. Firstly, finding the sum. Then secondly, finding the number of terms. Then using the general sum. And lastly, divisibility problems. So in the first question here, we are given the series and we need to find the sum to 20 terms. First, we're going to check that this is an AP. So term 2 minus term 1 is negative 1 minus 5, which is negative 6. And term 3 less term 2 is negative 7 minus negative 1, which is negative 7 plus 1, which is also negative 6. So we know it's an AP with common difference D equal to negative 6. We have to find the sum to 20 terms. So we're going to start by writing down what we have and what we need to find. We have A, the first term, it's 5. We have the common difference D, which is negative 6. We have to find the sum to 20 terms, so n is 20. And we need to find S sub 20. So we use a sum formula. S sub n equals n over 2 into 2a plus n minus 1 times d. Then just plugging in, n is 20, 2 times a, 2 times 5. N is 20, so n minus 1 is 19. And d, of course, is negative 6. Now we work this out on a calculator. And we see that our answer comes to negative 1040. In the second question here, we have to find the sum of the sequence. So once again, we can start by checking that it's an AP. So term 2 less term 1 is 0 minus negative 4, which is 4. And term 3 less term 2 is 4 minus 0, which is also 4. So this is an AP with common difference 4. Now in this question, we are not given the number of terms, but we are given the last term. Let's write down what we have and what we need to find. See, we've got the first term A, which is negative 4. We've got the common difference D, which is 4. We don't have n, and we have to find S sub n. We are given the last term though, so T sub n is 312. So we're first going to use the formula T sub n to get the number of terms before we find the sum of the sequence. So T sub n equals A plus n minus 1 times d. 312 equals negative 4. We need to find n, and d, of course, is 4. We can take the negative 4 to the left-hand side. So 316 equals 4 into n minus 1. And hence n minus 1 is 316 divided by 4. Let's see what that comes to. So it's 79. So the number of terms then will be 79 plus 1, which is 80. So now that we have the number of terms, we can use a sum formula. So S sub n equals n over 2 into 2a plus n minus 1 times d. And we plug in, we want S sub 80, since we have 80 terms. So 80 over 2 into 2a. And of course, a was equal to negative 4. So 2 times negative 4 plus 80 minus 1 is 79. And d was 4. So let's work that out on a calculator. 4 into 2 times negative 4 plus 79 times 4. And we see that it comes to 12,320. Let's look at your answer to the first question here. We have to find the sum to 15 terms of the series. So let's check whether it's an AP. So term 2 less term 1 will be 10 less 6, which is 4. And term 3 less term 2 is 14 less 10, which is also 4. So this is an AP with common difference 4. We have to find the sum to 15 terms. Let's write down what we have and what we need to find. We've got the first term a, that's 6. The common difference d is 4. The number of terms is 15. And we have to find s sub 15. So then just using the sum formula, s sub n equals n over 2 into 2a plus n minus 1 times d. We substitute in. So it's 15 over 2 into 2 times 6 plus 15 minus 1 is 14 d. And we can work this out on a calculator. And it's 510. So then the sum to 15 terms is sub 15 is 510. In a second question here, we have to find the sum of the sequence. Let's first check that it's an AP. So term 2 less term 1 is 4 less 9, which is negative 5. Then term 3 less term 2 is negative 1 less 4, which is also negative 5. So this is an AP with common difference negative 5. We have to find the sum of the sequence. So let's write down what we have and what we need to find. We have the first term a, it's 9. The common difference d is negative 5. we don't have the number of terms, but we are given the last term, T sub n. And we have to find S sub n. So we're first going to use the formula T sub n equals A plus n minus 1 times D in order to find n. So substituting n, solving for n, we can take the 9 to the left-hand side. Dividing by -5. And this is 23 on a calculator. So we see that n, the number of terms, is 24. 23 plus 1. Now we can use a sum formula. So S sub n equals n over 2 into 2a plus n minus 1 times d. And we want S sub 24. And of course a was equal to 9. So 2 times 9 plus n minus 1 is 24 minus 1, which is 23. And d was -5. So then just working this out on a calculator. And it's -1164. In the first question here it says, determine the number of terms in the following arithmetic series. So we're given this series. We can start by writing down what we have and what we need to find. We've got the first term a, which is -5. We can find the common difference d by taking term 2, which is -1, less term 1, which is -5. So this is -1 plus 5, which is 4. We don't have the number of terms. This is what we need to find. But we do have the sum to n terms, which is 897. We're going to use the formula S sub n equals n over 2 into 2a plus n minus 1 times d. And substituting in values, S sub n is 897. N is what we need to find. A, of course, is -5. And D is 4. Let's simplify. So it's n over 2 into -10 plus 4n minus 4. Just multiplying out the brackets here. We can simplify inside the brackets by adding like terms. So it's 4n minus 14. We want to get rid of this fraction here. So we're going to multiply both sides by 2. So on the left-hand side, we have 897 multiplied by 2, 1794. So 1794 equals, on the right hand side the 2's cancel when we multiply through by 2, so we're left with n into 4n minus 14. Now we multiply out the square brackets. We can write this on the left-hand side. So 4n squared minus 14n equals 1794. We can bring everything to one side. So 4n squared minus 14n minus 1794 equals 0. We could, of course, first simplify this equation by dividing through by a common factor, but we're going to use the quadratic formula, so we won't bother to do that. And remember, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So it's all over 2a. In this case, the variable that we want to solve for is n. So then, using the quadratic formula, we see that n equals negative b. Now, b in this equation, which is a quadratic equation, is negative 14. So negative 14 plugged in here will give us plus 14, because it's minus negative 14. Then plus or minus the square root of b squared minus 4. A, of course, is 4. 4ac, and c is negative 1794. This, of course, is all over 2a. So it's all over 2 times 4. So we have to evaluate the right-hand side of this equation. We can first work out what's under the square root, and we see that it's 28,900. Now, we must round off only the final answer. So n is 14 plus the square root of 28,900 all over 8, or n is 14 minus the square root of 28,900 all over 8. This answer will be invalid because it will give a negative value, and n is the number of terms, so it can't be negative. So it's invalid. Then, evaluating the square root of 28,900, we see that it comes to 170. So n will equal 14 plus 170, all divided by 2, and that comes to 92. In the second question here, it says, determine the smallest value of n for which the series is greater than 800. We are not told that this is an arithmetic series, but it's clear that it is, with a common difference d of 3. So let's start with writing down what we have and what we need to find. We have the first term a, which is 1. The common difference d is 3. S sub n, the sum to n terms, must be greater than 800. And we need to find n. So we're going to use a sum formula. So S sub n this must all be greater than 800. We can plug in values. We don't have n. We have a, it's 1. And we have d, it's 3. We can get rid of this fraction by multiplying both sides of the inequality by 2. So multiplying through by 2, the 2's will cancel here, so we're left with n. We can also simplify inside the square brackets. And multiplying the right-hand side by 2 as well gives us 1,600. Still simplifying inside the square brackets. And we can multiply the n into the brackets. and this is all greater than 1600. We can now bring the 1600 also to the left hand side, and we end up with a quadratic inequality which we need to solve. So we have to solve for n in this inequality. We can first solve it as an equation using the quadratic formula on the side. So n will equal negative b. B of course is negative 1, so negative b will be plus 1. Plus or minus the square root of b squared minus 4. A of course is 3. So 4ac, and c is negative 1600. And this is all over 2a. So over 2 times 3. So let's see what this comes to. 1 plus or minus. We can first solve the square root. And it comes to 138,567, etc. Of course, we always only round off the final answer. So this is all over 6. Now, n must be a natural number since it's a number of terms. So we can ignore the negative answer we get out of here and take only the positive. So 1 plus or minus, or rather 1 plus 138,567 over 6. So plus 1 divided by 6. And it comes to 23,26. Now, as we said, n is a natural number. It can't be a decimal. And in any case, we had to solve this inequality. So using our answer here, we see that n must be greater than 23,26. And n being a natural number, the smallest natural number greater than 23,26 is 24. So n equals 24. Let's look at your answers to this question. In the first part it says, determine the number of terms in the following arithmetic series, and we are given the series. Let's start with what we have and what we need to find. We have the first term a, it's 10. The common difference d we can get by taking term 2 less term 1. We're also given the sum to n terms, which is negative 238, and we have to find n, the number of terms. We're going to use a sum formula. So, substituting in values, we have to find n. A we saw was 10. And d was negative 3. We can multiply both sides by 2 to get rid of the fraction here. So the left-hand side is negative 476. On the right hand side, the 2's cancel here, and we can also simplify inside the brackets. Adding like terms inside the brackets and multiplying the n into the brackets. Now we can take everything to the left hand side. And we end up with a quadratic equation. We can now use the quadratic formula to solve for n width. So n will equal negative b, and b is negative 23, so negative b will be positive 23, plus or minus the square root of and it's b squared minus 4a. A is 3, so 4ac, and c is negative 476. And this is all over 2a, so 2 times 3. We can first work under the square root. This is all over 6. And it's 6241 under the square root. So then n will equal 23 plus the square root of 6241 all over 6 or n will equal 23 minus the square root of 6241 all over 6. So all over 6. Let's see what this comes to. And the answer is 17, so n is 17 here. Now, this answer will be invalid. Because n is the number of terms, it must be a natural number and it can't be negative. This will give us a negative answer and hence n is invalid. So n equals 17 only. Let's look at your second answer. It says, determine the smallest value of n for which this sequence, or series rather, is greater than 400. Let's write down what we have and what we need to find. We have the first term a, which is negative 4. We can get the common difference d by taking term 2 less term 1, so minus 1 minus negative 4. And that's negative 1 plus 4, which is 3. We don't have the number of terms, but we are told that the sum to n terms must be greater than 400. Once again, we're going to use the sum formula. So S sub n is n over 2 into 2a plus n minus 1 times d. This being S sub n, it must be greater than 400. So n over 2 into 2a plus n minus 1 times d must be greater than 400. We can multiply by 2 on both sides to get rid of the fraction here. And we can also simplify inside the square brackets. Multiplying the right hand side also by 2, we get 800. We can add like terms inside the square brackets. Multiplying in the n. And we can bring the 800 to the left hand side as well. So we end up with a quadratic inequality in n, which we need to solve. We can first solve this as an equation using the quadratic formula. So n will equal negative b. And of course b is negative 11. So negative b will be positive 11 plus or minus the square root of b squared minus 4a. A is 3, so 4ac, and c is negative 800. This is all over 2a. We can first work under the square root. So let's do that. And it's 9721 under the square root. So 9721, and this is all over 6. So then n will equal 11 plus the square root of 9721 all over 6, or n will equal 11 minus the square root of 9721 all over 6. This is going to give us a negative answer for n, so this is invalid. Let's see what n comes to here. And we see that n comes to 18,26. So 18,26. This, however, is solving n as an equation, or in an equation. We actually have a quadratic inequality here. So that means that n, since this inequality is greater than 0, it means that n is greater than 18,26. Now, n is the number of terms, so it's a natural number. The smallest natural number greater than 18,26 is 19. So n then will equal 19. Now, to go back to the original question, we needed to find the smallest value of n for which the series is greater than 400. So n is equal to 19. So this is the smallest number, 19, the smallest number of terms for which the original series will be greater than 400. In the first part of this example on the general sum, it says, given the arithmetic sequence 1, 5, 9, etc., find the sum to n terms. Now, another name for the sum to n terms is the general sum. So let's see how we can get this. We only need the values of a and d to write out the general sum. So a is the first term, and that's 1. D is the common difference, So we can take term 2 less term 1. So 5 minus 1, which is 4. Now we use a sum formula. So S sub n equals n over 2 into 2a plus n minus 1 times d. And we merely substitute in the values of a and d. So we get S sub n equals n over 2 into 2 times a, so 2 times 1, plus n minus 1 times d, and d is 4. So we can simplify inside the square brackets. So it's 2 plus, we can multiply the 4 into the brackets here. So it's 4n minus 4. Then adding like terms inside the square brackets, we get 4n minus 2. Now we can multiply the n over 2 into the square brackets. So 2 into 4 twice, and then n times n is n squared. So it's 2n squared. And then 2 into 2 once times n is just n. So the general sum S sub n equals 2n squared minus n. In the second part of this example, it says, find the 10th term of an AP if the sum of the first n terms is given by S sub n equals 3n squared plus 2n. So here we are given the general sum, and we need to find the value of the 10th term of the AP. Now, before you look at the answer, let's have a discussion on how to find the value of a term when we have the general sum. So let's consider the sequence, or the arithmetic sequence, T1, T2, T3, and so forth. So we have the sum of the first two terms, which we write as S sub 2, and this is T1 plus T2. Then we also have the sum of the first three terms, which we can call S sub 3, which is T1 plus T2 plus T3, etc. Now, let's say we want the first term, T1. T1 is given by S1. So the first term will be given by the sum to one term. Then T2 will be given by S2, the sum of the first two terms, minus S1. So S2 minus S1. Then the third term, T3, will be given by S3 minus S2, and so forth. So in this case, we must find the value of the 10th term. So T sub 10 will be given by S sub 10 minus S sub 9. And we can get S sub 10 by plugging in 10 for n in this equation, or into this equation. So it's 3 times 10 squared plus twice 10. And this is 320. And we can find S sub 9, the sum to 9 terms, by plugging in 9 for n. So 3 times 9 squared plus twice 9. We can work this out on a calculator. So 3 times 9 squared plus 2 times 9. And it's 261. So now we can get the value of the 10th term by taking S sub 10, which is 320, minus S sub 9, which is 261. So let's see what that comes to. So 320 less 261, and that gives us 59. So the value of the 10th term then is 59. Let's look at your answers to this question. In the first part, it says a sum to n terms of a sequence is given by this equation, and we need to find the value of the fifth term. So we are given the general sum, and we have to find t sub 5 or t5. Now, the fifth term is given by the sum to 5 terms less a sum to 4 terms. So the sum of the first 5 terms minus the sum of the first 4 terms. Let's work out S5 and S4. S5 we get by plugging in 5 for n. So 5 into 5 plus 2. That's 5 times 7, which is 35. And S sub 4 we get by plugging in 4 for n. So it's 4 into 4 plus 2, and that's 4 times 6, which is 24. Now we can easily work out T5, or the fifth term. It's going to be S5, which is 35, minus S4, which is 24. And this equals 11. Let's look at your answer to the second question here. We are given this general sum of an AP, and we must find the first 3 terms. So term 1 is given by S1, the sum to 1 term, and we can get this by making n equal to 1 in this equation. And we see that this comes to 20. Then term 2 we can get by taking the sum to 2 terms less the sum to 1 term. So S1, and we can work out S2 by making n equal to 2 in the equation. And in less S1, which is the same as T1, so less 20. And this works out to 34. So 34 minus 20, of course, is 14. So this is the second term. We could find T3 in the same way by taking S3 less S2. But perhaps a quicker way of doing this now, since we have the first 2 terms, is to find the common difference D. So it's going to be term 2 less term 1. And this is negative 6. Now to get the third term, so T3, we add D, the common difference, to the second term. So 14 plus negative 6. And this, of course, is 8. Then to write down the AP, the first term was 20. So 20. The second term is 14. And the third term is 8. Let's look at example 3D, which deals with divisibility in the context of arithmetic sums or series. We are given this arithmetic sequence, and in the first question it says, determine a formula for the nth term of the sequence. This is another way of asking us to find the general term. So we need the values of A and D in order to find the general term. A is the first term, and that's negative 3. D is the common difference, and we can get it by taking term 2, which is 1, less term 1, which is negative 3. And this is 1 plus 3, which is 4. Now we use the formula T sub n. So T sub n is A plus n minus 1 times D. And we substitute in the values of A, which is negative 3, and D, which is 4. We can simplify. We can multiply the 4 into the brackets. And adding like terms, we see that the general term comes to 4n minus 7. In the second question, it says, write down the values of the 4th, 5th, 6th, and 7th terms of the sequence. So we have the first 3 terms. The 4th term, t sub 4, will be 5 plus the common difference of d. And we saw earlier that d was 4. So it's 5 plus 4, which is 9. Then we also want the 5th term. We add 4 to the 4th term, so that's 13. The 6th term is 13 plus 4, which is 17. And the 7th term is 17 plus 4, which is 21. So we have the values of the 4th, 5th, 6th, and 7th terms. In number 3, it says, write down the remainders when each of the first 7 terms of the sequence is divided by 3. Let's start by rewriting the terms. So it's negative 3, 1, 5, then term 4 is 9, then 13, 17, and 21. The last term, of course, is 393. So let's now write down the remainders when we divide the first 7 terms each by 3. 3 goes into negative 3, so the remainder is 0. 3 doesn't go into 1, so the remainder is 1. 3 goes into 5 once, we have a remainder of 2. There's no remainder for 9. 3 goes into 13 4 times, and with a remainder of 1. Into 17, 3 goes 5 times with a remainder of 2. And into 21, there's no remainder. So these are the remainders when the first 7 terms are divided by 3 each. Coming to the last question here, it says, calculate the sum of the arithmetic sequence that are divisible by 3. So for this original sequence, we must find the sum of all the terms divisible by 3. And we can use the answer to the third question. We have the terms that are divisible by 3. Those are the terms with remainder 0. So it's negative 3, 9, then it's 21, etc. And then also 393, the last term, is divisible by 3. So we have a new arithmetic sequence of terms divisible by 3. And we must find the sum of the sequence. So let's see what we have and what we need to find. We have the first term a, which is negative 3. The common difference d we can get by taking term 2 less term 1. And we see this comes to 12. We can check to see that this is an AP by taking term 3 less term 2. And we'll also get 12. We are also given the nth term, or the value of the nth term, which is 393, and we don't have the number of terms. So we're first going to use the formula T sub n to get the number of terms. So then just substituting in, 393 must equal negative 3 plus n, which we don't have, times d, which is 12. And we can solve for n. We can bring the negative 3 to the left-hand side. So it's 396 equals 12 into n minus 1. We can divide by 12. So 396 divided by 12. And we see it comes to 33. So then n is 33 plus 1, or 34. Now we can use a sum formula to find the sum of all these terms. So S sub n equals n over 2 into 2a plus n minus 1 times d. And we want S sub 34. So 34 in for n. Our first term a, of course, is negative 3. Negative 3 plus n is 34, so 34 minus 1 will be 33. And we saw that d was 12 for this new AP. Now just plugging into the calculator. And it's 6630. So the sum of all the terms divisible by 3 in the original sequence is 6,630. Let's look at your answer to the first part of question 3D. It says the first three terms of an arithmetic sequence are 2k minus 7, k plus 8, and 2k minus 1. And in A, we have to calculate the value of the 15th term of the sequence. We're going to use the fundamental property to find k. So T3 less T2 must be the same as T2 less T1. And then just substituting in. So it's going to be 2k minus 1 minus k minus 8. The sign changes when we subtract k plus 8. And this must equal k plus 8 minus 2k plus 7. We can add like terms on both sides. So we have k minus 9 equals minus k plus 15. And in solving for k, we have 2k equals 24. And we see that k is equal to 12. Now we can write down the values or the numerical values of these terms. So we have a new AP, or rather we have an AP. And it's the first term is 2k minus 7, so it's twice 12 minus 7, which is 17. And in the second term is k plus 8. So it's 12 plus 8, which is 20. And the third term is 2k minus 1. So 12 times 2 minus 1, and this is equal to 23. So the AP then will be 17, 20, 23, etc. Now we must find the value of the 15th term. So we're going to use T sub n, so T sub 15 equals A, and our first term is 17, A is 17, plus n minus 1 is 15 minus 1, which is 14, times D. In this case, the common difference D is 3. We are adding 3 each time to get to the next term. So it's 17 plus 42, which is 59. In B it says, calculate the sum of the first 30 even terms of the sequence. Now, we saw that the first 3 terms were 17, 20, and 23. We're going to add a couple more terms to see whether we get a pattern. So the common difference is 3, and adding that to 23, we get the fourth term, which is 26. Then it's 29, 32, etc. we must find the sum of the first 30 even terms. And we see that 20 is an even term, then it's 26, and then 32. So every second term is an even term. So we have a new AP consisting only of even terms, which is 20, 26, 32, etc. In this case, the first term is 20, and the common difference D is 6. And we can use a sum formula to find the sum to 30 terms. So S sub n is n over 2 into 2a plus n minus 1 times D. And just substituting in our values, so it's 30 over 2. So we want S sub 30 into 2a plus n minus 1 is 30 minus 1, which is 29, times D, which is 6. And we can find this on a calculator. And it comes to 3,210.